Hi, I'm Mary Fowler, and this is the third video in a series of videos about how to use statistics to prove racial profiling in court. From a statistics perspective, there are three main things we need to do. First, we need to consider who the police officer is observing. So that is, we need to estimate the racial distribution of the observed population of the police officer in question. The second thing is to estimate the racial distribution of individuals subjected to a police action. And the third thing is we need to compare those two distributions. So in this video, I'll be referring to a number of cases, and these are the details on the cases, and I'll be referring to them by the last name of the defendant. So we want to consider the two distributions that we need to compare. So the first one is, who is the officer seeing? So the racial distribution of the observed population. And for an example that we can just hold on to, we sometimes can consider the racial distribution of drivers if we're considering the police action of of drivers receiving a citation. So kind of as one of the main examples, we'll refer back to citations and race of drivers. So in this situation, we need to estimate the proportion of observed drivers that are Black. And some options to estimate or measure the percent Black of the observed population of the observed drivers could be a direct observation, like looking and seeing, having an investigator look and see and record the race of the individuals that are passing the investigator. We can look at the residential population in an area, and that in certain situations is a better idea than in others, depending on the kind of road that we're talking about. And also, we might consider the race of the individuals receiving citations by other police officers, and that other police officers and the racial distribution of the individuals they're stopping at a given location, we might consider that to be a way to get an idea of what's going on, who that officer is observing. And then the second distribution we need to consider is the racial distribution of individuals subjected to a police action. So we might consider drivers receiving a citation. We need the racial distribution then of the stopped drivers. So first of all, in order to get that, there might have to be some requirements that the race of the driver being stopped is recorded on the citation or somewhere in the train of paperwork around the police action. We could look at citations or warnings, for example. Okay, and so here are a couple of examples of how citations are used in the cases that I outlined earlier. So in the Soto case, a random sample of citations was used to estimate the racial distribution of police actions. That was in the 1990s. So the availability of data management was different. Stepping forward, we can look at all citations more easily now in the 2020s here. So we can also look at citations written by officers involved in the stop in question. So now in Laura and in Long, we use the citations written by the officers to estimate the racial distribution of the individual subjected to that police action. So that's a pretty direct way of measuring. And then citations in the Zarilla case, I looked at all the citations written by officers in the barracks that the officer in question was part of. And I split those citations into two groups. I looked at From the barracks, I considered the citations written by the officer involved in the stop, and I compared that to citations written by all the other officers in that barracks. And we could also have consider, when we're doing this sort of using citations of colleagues, I call them benchmark colleagues. Often it's important also to consider the location information that's recorded in the citations. If you're going to compare officers to officers, it's important to pin down location. Okay, so examples of direct observation. In Soto, there were 2 examples of direct observation: that an investigator drove a car 5 miles over the speed limit, and the race of drivers passing the investigator's car was recorded. And this estimates the racial distribution of who the officers are seeing, the observed population. Also, as an alternate measurement, the investigators observed the highway from an overpass, and the race of drivers recorded also estimates the racial distribution of the observed population. In more recently in Boston, in an urban neighborhood, an investigator was used in the Van Rader case to record the race of pedestrians and drivers passing the investigator. So we're going to now bring together the police in the Soto case. We're going to bring together the 2 distributions and then introduce the comparison method. So the details of this stop is that there was a motion to suppress drug evidence seized after traffic stop on the southern end of the New Jersey Turnpike. And that is a major road. So to my knowledge, this was the first racial profiling case in the United States. So the police actions were measured by a random sample of citations from troopers in 1 barracks written on the New Jersey Turnpike. And in that random sample, 46.2% of the tickets that had race included recorded race as Black. So there was an issue with missing data. The race was not included in on many of the citations. So that's an example of why we really do need to have sort of guidelines or requirements for recording police actions, race of individuals subjected to police actions. And then the observed population was observed using the direct observation, and the investigator set a cruise control at 60 miles per hour when the speed limit was 55. Almost everybody passed him. 98.1% of drivers passed him. 15% of the cars were driven by Black drivers. So we need to compare the 46.2% of race identified tickets to Blacks to the 15% of the the cars that were observed passing the investigator were driven by Blacks. And the method of comparison is the probability ratio. In the probability ratio, we calculate the probability of being stopped given the driver is Black with the probability of stopped given the driver is white. And there are some probability calculations that lead us to this probability ratio being over 4.86. This can be interpreted as the probability of stopped given the driver is Black is over 4 times that of the probability of being stopped given a driver is white. So another way to measure or estimate the racial distribution of the observed population could be by using residential population. So this is sort of both been successful and unsuccessful depending on the road type. So the residential population is measured by the census or the American Community Survey and can be used in certain cases as a benchmark for the observed population. So the Laura case was a stop on a major road in Massachusetts, the Route 290. And in the analysis, the racial distribution of the observed population was estimated or benchmarked with the census from the towns of Auburn and Worcester. So the issue with this is that in a major road like 290, there are many people driving from one location to another that really are not included or involved in the residential population in the area. So the Massachusetts court did find that that was not a sufficient way to estimate the observed population on a major road. So residential population was again used in the Brown case, much more a few years ago, in an urban neighborhood in Boston. And here, the racial distribution of the police district that the officers were involved in. So just looking at was used to estimate the racial distribution of the observed population. So that really was not a very tight comparison, in that our officers might or might not have been patrolling the entire police district. So then the residential population was used successfully in the Long case. And in the Long case, again, it was an urban neighborhood in Massachusetts. And to get a really more detailed understanding of where our officers patrolled, each of the police action which was tracked, one of the police actions which was tracked was police reports, field investigation and observation reports, FIO reports. And using the address on each of these FIO reports, we're able to geolocate that address into a census block group, and then use the racial distribution in the census block groups together to understand what the patrol area looks like, what the officers are observing in the patrol area. So one way in which we use we can compare the distribution in the patrol into the residential distribution with the police actions in Michael Brown. We use the equality of proportions, the Z test of one proportion, that was referred to on the first video in this series. So the idea of comparing hypothesis testing of one proportion. So in this case, there were 39 citations that the officer had written, and the racial distribution from these 39 citations were compared to the racial distribution of the race in the police district. And we ended up with we used the Z test of one proportion to compare, and it yielded the p-value of 1.6%. So the percent Black of the observed population really is not available. So the sensitivity analysis allows us to answer the question, how high can the possible percent Black in the patrol area be and still show evidence of racial profiling? So in this analysis, the racial distribution of the police district was 47.93%. Yielded a Z statistic of 2.15 and a p-value of 0.016 or 1.6%. And what I did here was I increased the possible percent Black. And for each increase, we could see how the p-values decrease. And so the sensitivity analysis shows that if the percent Black in the observed population is 51% or less, there's statistical evidence of racial profiling. That is, the p-value is less than 0.05. So this sensitivity analysis sort of addresses two of our jobs remember the three statistical jobs we needed to do. So there is, in some sense, this is an estimation of the observed population and a comparison of the two distributions. So that's what the sensitivity analysis is used to answer the question, how high can the percent Black be and still show evidence of racial profile? Okay, I'll see you in the next video.